Okay, welcome everyone. I would like to start with this quote that I received from one of the interviews that I was performing in my research. And it's a very interesting quote according to me. We are a total cost of ownership driven market and not a nice to have feature market. And the world of business is quite practical, quite pragmatic. So I think that this quote, it sets the tone for the rest of my presentation today. With that being said, my name is Tyrone Machado, and today I'll take you on a journey towards business cases for automated and autonomous mobile machinery. I'm currently employed with Bosch Rexroth in Germany and enrolled as a PhD or doctoral student at Tampere University in Finland. Yes, so as we saw in the previous presentation by Antti as well, we saw the video of Novatron, and this was one of the first images that I created in the MORE project. And back in 2020, and if we all know that in the last 2 or 3 years, the world has changed a lot. And if we go back to the past, let's say a few decades ago, how was work structured? You had a lot of humans, a lot of people who were performing work processes. And then as time progressed, the machines became bigger, more efficient, more powerful, and we got a better idea of how to do work with, let's say, by replacing humans. But as time has progressed now, there are new societal challenges that have come across. So we have labor shortages, aging populations, and if you see like the placement of the people, I intentionally place them behind the machine or in front. Accidents, a lot of accidents take place due to heavy-duty mobile machinery. And that means that these societal trends, these broader societal trends, have brought in the need for new technologies. So electrification, connectivity, and automation, these are the 3 major trends that are shaping the mobile machinery industry at the moment. And we need more clarity about this. How do we go forward when we when we approach these trends simultaneously? It's not as I started, it's a total cost of ownership market. Yeah. And in my research, I try to bring a little bit of clarity to the technology, to the business, economics, a little bit of safety, and overall sustainability. Yes. So with that, I had 3 primary research questions. The first one is to figure out the levels of automation in the mobile machinery industry and the key enabling technologies. The second one is to figure out the drivers and barriers of automation. So can we assign priority to a particular concept based on the certain drivers and barriers? And then the third one is to design new business models to maximize the value for different stakeholders. And as you see here, we have the 3 arrows. You have sense, you have seize, and transform. This is the dynamic capabilities framework where you have to sense opportunities, you seize opportunities, and you transform opportunities. So then we ask the question, what is automation? So in very simple words, automation is when a task that is previously performed by a human is now performed by a machine. We saw it in the previous presentation as well. There were different strategies for different levels of automation. So we have developed this concept called the levels of automation matrix. So according to this matrix approach, it's not we automate the task, we don't automate the machine itself. So during a particular work task, the machine can switch to different levels of automation. And this is how we developed this levels of automation matrix. There's different definitions. We build on the SAE 3016 levels of automation. So no automation is quite simple. It's completely manual. Operator assistance systems, partial automation, conditional automation, high automation, and full automation, which is autonomy. But then how do we move up a different level of automation? So here we consider these 4 system parameters or human-machine interaction parameters. So as we have system control, environment perception, decision-making, and worksite communication. Now, I'm no magician, but sometimes a frog can appear out of a cat. So just assume that I am the mobile machine right now and the frog is the operator. So if you consider this, system control is about, does the frog control me or am I making the decisions on my own? Environment perception, is the frog looking around me or am I looking around? Yeah. Decision making, does the frog make the decisions about where I'm supposed to go? Am I supposed to move here or is it my own decision? And then you have worksite communication. Who communicates with the machines on the worksite? Yes, and as you see here, you have different enablers of these human-machine interaction parameters. Yes, and that means that as you move up a level of automation, things become very complex. How complex? We figure out in the next slide. So, I'm missing the references here, but this was the paper that all the ESRs in the MORE project, we contributed to it together. So, autonomous mobile machines, on one side, you have the process where you have machines interacting with other machines, with other humans, or let's say the process. And on the other side, we have the machine as a single unit of analysis. So you have the automation domain and you have the hardware domain. So in the automation domain, we look at things like perception, navigation, control. And in the hardware domain, we look at more at the powertrain architecture, system architectures. And in the process domain, we look at the whole business, the work, how the business is structured, how the work is structured, how we simulate the environment, and so on. So, as you see here, there's a lot of topics that exist to develop and deploy. So, the key here is to deploy, yeah, and develop. So this gets very complicated, and then the roles of different actors, they get complicated as well. And that's why we need to understand how the industry is structured. So if you look at the typical value chain in the industry, so in the previous presentation, we saw a lot of it from the perspective of construction, so the end user perspective, if we consider the bubbles here. But before it reaches the end user, how is this industry structured? So if you start from left to right, you move in the value chain. You have the suppliers, they have certain expertise with products, with software, with system architecture. They provide components, they provide technology. They give it to the OEM, the original equipment manufacturer, who is the system integrator. So they bring in the different product system or software and they integrate it into a machine. They provide, or they take the responsibility and liability for the machine. Now, once it goes beyond that point, it's either sold to the vendor or a dealer. And from there on, it can be either be sold to the rental company, contractors, infra owners, and so on. So the value chain is quite diverse, and this is something that I figured out by conducting interviews in the mobile machinery industry. So, firstly, the mobile machinery industry is a project-based industry. So, we start a particular or new initiative as a project, and this means that the stakeholders in the mobile machinery industry are analyzed heuristically, not in an ad hoc manner. So the key characteristic of the mobile machinery industry is that it's a low volume industry, it's a high variance industry and high cost industry, which means that as we move up the levels of automation, things become expensive. Developments become expensive, deployments become expensive as well. And this is, as you see here, the stakeholder map. The dotted bubbles, let's say, they are the new stakeholders that we can expect in the mobile machinery industry. At the moment, you have a lot of stakeholders, let's say. And, and it's not just that the key here, again, I would like to stress, it's development and deployment. And that's why you require more stakeholders, like academic stakeholders, you need governance stakeholders, you need societal stakeholders, and you need to find a way to collaborate with these different stakeholders. And then all these different stakeholders, they're going to value something different. So this is something that we try to develop. We try to create different dimensions of value. What matters to the mobile machinery industry? Yes. So firstly, economic. Everything is about money. As I mentioned in the starting quote, total cost of ownership driven market. So with the economical dimensions of value, we consider economic value, that's profits, capital expenditure. Then we have total cost of ownership. So let's take the example. If I have a phone, let's say this phone is 100 euros. Yeah. It's 100 euros. If I bought this in 2018, that's the cost for me, that's the purchasing cost. But until now, for the 5 years after 2018, I've spent money on recharging it with a mobile internet plan and charging the phone and having the infrastructure to charge the phone. That is total cost of ownership. Then we have productivity, doing more with less, and we have funding. So as I mentioned, the project-based industry, you require money, you require funding to initiate projects, to continue the projects. Then we have the second dimension of value, which is legitimacy. So this one is a dimension of value that cannot be measured in absolute terms. It's more of something that's at the back of your head. So legitimacy, automation is something new. We need to create legitimacy. And what do I mean? I can give an example. So how have electric cars become so important in the society today? Somebody created legitimacy for them in the past few years. That was Elon Musk. So you create legitimacy for a product, and then the product or a service or a technology, it progresses further. So that's legitimacy, the first dimension of value. Then we have recognition. The mobile machinery industry is a very traditional industry. As Antti mentioned, the construction industry is not digitalized. And this means that the reputation of every organization, it needs to be proven again and again, especially when you're introducing something like automation. The industry has been structured with, let's say, hydraulic or fluid power technology for the past few decades. This has not changed until the past few years. So that's about recognition. And then values and morals. Everyone has certain values, morals that they live by, and so do organizations. Then we have sustainability dimensions of value. These have become very important in the past few years. Firstly, environmental sustainability. So we consider people, planet, performance. And then we have carbon dioxide emissions. So these are more about energy efficiency. Safety. So when we introduce automated and autonomous mobile machines, they need to be safe or safer than human operators. And the concept of safety itself will change in the future. Then we have technical dimensions of value. Firstly, robustness. It's one thing to create an autonomous excavator or autonomous, let's say, mobile machine as a proof of concept. It's another thing to create, let's say, 1,000 or hundreds of excavators or automated mobile machines with a parameter concept, with a scalable concept. Yes, so that your machine has to be robust for different environmental conditions. Then we have maintenance. There's a key thing that as we move up levels of automation, the human operator gets separated from the machine. So we need to figure out how to maintain these machines, how to keep them up, to maintain uptime, reduce downtime, and so on. Ease of use and comfort, quite closely related to each other, but as we go up the levels of automation, we bring in new things to the machine. We bring in human-machine interfaces, or human, for example, here we have interfaces. So we need to consider this in the mobile machinery industry, that now you need to consider user interfaces and not just joysticks or foot pedals and so on. And then we have social dimensions of value. So as I mentioned earlier, labor shortages, aging populations. So mobile machines should be able to contribute to regional impact, creating tax, increasing tax revenues, creating jobs, education of workforce, future of workforce, and then publications. This is more about academia. So we were having this discussion earlier as well. For some listed companies, it may make sense to have publications for their, let's say, for their annual reports to show the world that they're contributing to science. So these are the different dimensions of value that I figured out from the interviews that we performed of the mobile machinery industry. And then if we look at some trends, automation-related trends on the same data set. So firstly, the biggest trend is that we are increasing the levels of automation, gradually increasing, not moving, skipping generations. So we go one step at a time, and that's so levels of automation only for process, task automation, so one step at a time. The next thing is automation is new, as I mentioned, and we need to create legitimacy for automated solutions in the industry, especially with end users who are not very digital, who may be used to very old processes, pen and paper processes. Yes, and then there are several optimization possibilities. We will see that in some other presentations today as well, tomorrow, that there's different optimization possibilities on how you can achieve automation. Then mixed fleet operations, these are very important, especially from an end user perspective. They don't use just a single fleet, or they don't use just a single brand of machine or a single type. They use different brands, different types, different sizes of machines. And these need to be considered in, let's say, automation. And this is where, let's say, add-on solution providers have an added advantage, because they can provide solutions for mixed fleets. Yes, and then if we see some others, teleoperations, as we saw in the previous presentation as well, remote operations. Multiple machines can probably be controlled by one operator, and that's a trend that's taking place. Even we could see that at Bauma this year, a lot of solutions that were presenting teleoperations. And system of system solutions, here we need to look at the whole process and not just one single machine. The whole process, the whole system needs to be considered in developing automated automation solutions. And then if we consider some drivers of automation, the biggest driver, of course, it's skilled labor shortage. It doesn't matter how good machine you create, how efficient, how big, powerful. If you don't have humans to operate it, then it's pointless to some extent. And this is the biggest driver of automation today, that it's becoming difficult to find machine operators. And then the second biggest driver is economic value. With automated machines, and it's quite closely related to predictability and productivity. When you bring in automation, you bring in predictability to the process, and you improve the productivity. Of course, with more developments, things will become even better. We need more data about this. And better safety. So if you have sensors around the machine, it's easier to look around the machine and make decisions. So automated machines should bring in better safety, and this is one of the drivers of automation. Then some other drivers are, let's say, the legislation is moving. They're trying to create standards, or they're trying to create regulations to accommodate for artificial intelligence and autonomous machines. The digitalization and BIM, as mentioned earlier, that's an enabler of automation. Even in your daily lives, people are getting used to smartphones and so on. So, and then if you look at the barriers, they are much more than the drivers of automation. So one of the biggest barrier here is safety related. So if you see humans in the work environment, so operating around humans, operating around other machines, it's a very complicated task. That's one of the biggest barriers for automation. It's as even in the previous example, automation on a railway track is relatively much more easier than a construction site where you have people walking in or machines walking in and or driving in and out. So safety is one of the biggest barriers. Then we have legislation. It's not moving fast enough. And there was a quote that unless legislation moves, the industry does not unless legislation moves, the industry will move. Or let's try to rephrase this. If legislation moves, the industry moves. And the same thing, the industry says, legislation says that if industry moves, we will move. And this is a conflict, sometimes it's a conflict. Yeah. Then skilled labor shortage. Now this is a different type of skilled labor shortage. It's something that we are sitting in this room. This is more about talent with respect to artificial intelligence, robotics, data analytics. So the talent shortages that are happening in the world today. That's one challenge or barrier to automation. Mindset of end users. Some end users, they are not, let's say, accepting of digitalization, especially because they have performed these processes for 10 or let's say the last few decades with pen and paper. They just cannot change. And this is our task to find out how do we overcome this barrier, for example. Technology advancements, yeah, sure, the sensors are becoming cheaper, but they're still quite expensive. There's still some issues with the technology that has to be used. Which technology do you use exactly? Which sensors, LiDAR, camera, LiDAR? Which one do we use? Yes, technology called mixed fleet operations. They again, they come up as a barrier to automation, or at least it makes it more complicated. There was a question earlier about hydraulics and electric drives. So that's fluid power robotics is considered as some sort of a barrier as well, because the dynamics are not so good of fluid power compared to electric. Yes. And then finally, we know the values, we know the drivers, we know the trends and barriers. We need to figure out, now this is ongoing work, I'm working with ESR, Amir Masood and Daniel. So this is about developing KPIs, key performance indicators for autonomous mobile machines. So we consider three things, or we plan to consider three things. Effectiveness. Here we try to figure out the availability of the mobile machine, the performance, and the quality of work. So if I just give brief examples, availability is about uptime, downtime, performance. So I can, let's say as an excavator, you can continue digging, but let's say if you find a pipe or something underneath, and then you need to fill that hole again and start digging again. That's the performance of the machine is still the same, but the quality of the work is bad. So that's effectiveness of the machine. Then we have efficiency. You have energy efficiency and CO2 emissions. We can extract this from the time data that we get from availability, performance, and quality. And economic value. We try to figure out the labor costs, downtime costs, infrastructure costs, planability costs. And here, if we develop this framework, a good enough framework, it can enable us to make comparisons between operator assistance systems, between teleoperated systems, between autonomous systems. And that's what we mean, the operational parameters for autonomous mobile machines. So, with that being said, I would like to thank you for your attention, and the answer to all your questions is, it depends. Or if you have questions about life, it's 42. Thank you.
Okay, maybe we have time for one question. Higher the risk is that total cost of ownership in the end won't be lower.
No, yeah, you're definitely right about that. So, in one of the slides I mentioned it's high variance, high diversity, low volume industry. So it's not always total cost of ownership. So let's say if we have small contractors who have their own machines, they care about just purchasing one machine. So for them, it's it's just the investment cost. But when you consider the bigger, let's say bigger customers of machines, they look at the total cost of ownership. For very low volumes, it's not so important. That's what I was getting from the interviews.